All right, welcome Core Academy, third lesson on the core stack. We are kind of be taking a step back from the compiler and the AST stuff and regrouping our thoughts about what's going on with those and some of the possibilities that are implied by the things that we've seen, and look at the actual structure of Hoon, Lol, and Zeus and why they are set up the way they are. Before next week, we'll get into Arvo and then the boot sequence. So we'll start to go into, how are we actually constructing Urbit as an operating system? Once you have the language, once you have the subject and all of these notions tied together there. Let me share this one. And let me get the chat open here so Gary can heckle. All right. All right. So, like I say, this one's probably a little bit lighter than the last couple, in that subject search and limb resolution is an interesting way of looking at like what's going on with faces, with tree axes, and so forth. Talk a little bit about the whole Kelvin scheme and some of the details that aren't necessarily present in the naive presentation of Kelvin versioning. And then, look at the actual subject structure when we're putting things together. So, okay, subject-oriented programming. We've done a lot of resolution of quantities against a subject. We have a knock. We can put a formula against a subject. We can create vases with types and slam. Slam gates, slam formulas against a particular subject to resolve everything. From the compiler's perspective, when we have what we want ultimately is the ability to retrieve a formula at some address. And so we can use knock 0 to look this up. We can use knock 9 to do it in kind of a more roundabout way. And what we would like to do is be able to access a formula at some axis in a tree and grab the noun there and then do something operationally with the noun. The most convenient way for almost all purposes is to use a face. So a face is essentially a label for an axis in a tree. And these showed up as send face inside of our type checker. They're a Hoon convention. Knock doesn't know anything about labels or faces. So the Hoon compiler parses and then inserts faces, uses these as references to look up values and nouns inside of our subject. There are things in Hoon you cannot do without name labels, just by the way Hoon itself is structured. That would not be true for a different Hoon that would always allow you to access a numeric, access data via numeric access. But knock knows nothing about labels or faces. These are all stripped out of knock. And we can largely, we can construct a lot of Hoon programs without labels if we're willing to do weird things with it. From a type perspective, so down here at the bottom, make that a little bit bigger for us. So I tisfaz, like a series of faces here, and then I can refer to things with these wings, right? These limb resolution paths. Dot is not a rune. It is a primitive part of Hoon syntax that simply means, resolve this face, resolve this label within the subject to my right. And this is why it reads from, sort of from right to left, because you have to resolve it against the subject encompassing it on the right. But as we pointed out last time, or maybe the first time, I think last time, it's not the same thing as a col, right? Like a col is a tisgal. It's kind of a broader way of expressing a similar idea, but this is a Hoon primitive way of looking up a value here. So now if I have, these types of statements here, tis faz A, B tis C, tis 5, the tis is actually short for ket tis, which modifies an enclosed expression to be wrapped in a face. So if I'm going to apply a type to this through the type sphere, then I'll see that, it has B tis, C tis, pat UD. And so this is included with the type information still, this face information. And if I repeat the same thing, but instead of resolving to type, I resolve to noun, then you can see that there's still a number of values in here. Pull these out as pat T's, and I see that these are faces. And so there's a face B, there's a face C. As is usual, the pretty printer kind of makes it hard to oh, I guess I needed that A resolved there. Resolve that through type, and then I can actually see the yeah, so there's the face, that's the face on the B, as I resolve that in. An arm name is not the same thing as a face. And so if I'm resolving an arm, this is a lookup value that the compiler locates, but it's not a face. So it is a label. It is something that gets searched and brought in. The difference is that a face is essentially a primitive reference to a noun. It's, it's just registering in a table. Here's the noun that this corresponds to in my current subject. The name of an arm is instead, what it does is it causes the arm to be fired, right? So if I go grab add, then this pulls the noun in, it swaps out the sample, so there's a modification that's made, and then it fires the buck arm when it slams it. And so there's a number of things that are entailed in referring to something via the name of an arm that are not entailed by just referring to something as a face. So
worth mentioning there is like like the A.B.C is like gets parsed as a wing. All these things are wings. If an arm appears, but it's not the foremost one, it refers to the whole core that's being referred to, which is why you'll see, like, I don't know, very like when you do if you look at like some like the skeleton agent or something, I think, or something, like you'll see like ... on in it, which like refers to the whole core of the agent.
Right, because that's because that gives us the subject of the core that we're in, and then we can play some games with that. Hey, Ted. We are talking about subject search and limb resolution and wings and all of this right now. So ultimately a wing, let's see, I have so a wing is a list of limbs where a limb is either a simple name, it's an axis in some other way by geometry, or if we're doing it this way, then we're including information about maybe, the number of skips that are involved with it or so forth. If we have kets that are involved with it. At the highest level, I like to think about this in three. There's sort of three ways that we can resolve an address and what's going on. So, relative means that we're using Lark syntax. We're doing these kinds of expressions here. We're saying, relative to whatever my reference point in this tree is, go locate this value for me. Absolute gives us numeric syntax. And so you've certainly seen less6, which is the tree address. There's also things like PAM6. This gets used with things like lists, and it's sort of automatically taking the next sequential element in it. And then there's a rather uncommon one, which is bar 6, which is, sort of a slag, like it takes the remainder after a certain address, which is kind of an interesting one there. And then of course, by name, which gives us face and arm names that get resolved there. These are actually resolved by rope. Let's go to hoon.hoon. This is hoon.hoon with nude duds, I suppose. Glowy nude duds. Okay, we're deep in the compiler here. All right, let's see. Rope. And in particular, let's see, Venn is what parses Lark syntax. And I suppose, I don't know what a bet and a tub is. This is the thing, is once you're down in the parser, there's a lot of special purpose names that are defined inside of that core that you often have to go look up. Like, I don't remember what a bet tub or a goal tub is without going and digging around for that. That's where Venn gets resolved. I've got a lot more notes on the parts of the compiler if you ever need to go back and look at this more. OpenAP does some of the wing resolution as well. There's a Musk arm inside of Axe. There's an Axe arm inside of Musk. Yeah, so this is actually resolving, within a particular context, can we resolve the wing against the sample supplied subject? So, you'll give it information about the subject that it's trying to resolve against here. This is where your depth first wing resolution takes place, right? So from the outermost or the closest match as you move in towards the inner core, this is where it's all here. So Christian says Axe is for expanding buck runes.
But I think like the Musk thing, I'm not sure. I'd have to take a look. I think if you just have it could be that if you just have no, never, like maybe it'll like contract like Lark syntax for you potentially. Because like Musk is for basically like doing some like basic knock analysis that like will turn like knock into constants or something potentially.
Well, it does more than knock, because this is also where you get things like given a spec, do a bunt. Like, what is the bunt of a
Yeah,
spec?
yeah. I was talking about
All these
Musk.
things are pieced in there. Yeah. Yeah, so Axe kind of is the super category. Yeah. I think the problem is that my notes were in the wrong order there. Yeah. Yeah, there's your Musk stuff there. So yeah, Axe is where you end up resolving this stuff. There's some interesting things like example. Example is the one that produces the bunt of it. So it consumes this Hoon information, this AST information, and then decides how to actually build something. Factory is how you make a mold given a spec, for instance, as an AST, which is kind of an interesting operation. So that would, I guess, an example of Axe would, let's see, somewhere I had a spec.
It's like buck cold, buck tiz, blah blah blah, buck tiz,
Yeah,
blah blah
okay,
blah.
here we go. Yeah, I've got an example of a spec one there.
One thing I found like quite sort of surprising when I first discovered this was that ket hep is not primitive. Like it boils down to like sort of like a ket lus ket tar that is like when you cast something and it actually says like cast to the type of the buns.
Let's see, you were saying ket.
Yeah, it is a little
Tiz.
surprising, but that's how it works.
I mean, it makes sense in hindsight because it's like, like basically, like, like the only way that like types are like generated to begin with are from compiling Hoon. So you have to like, like compile some Hoon, like that, like for the bunt, like that constructs the bunt to like have like the type of the value, um, and uh, and then like you can then like cast the type of that.
Yeah. And it's kind of an artifact of the fact that the thing at the end of the day, the thing you care about is the axis, and the rest of this is I'm not sure that sugar is the right word for it, because if something you need as a human programmer, unless you really want this to feel like an assembly, um, to end up with these clauses. Yeah, so here's bunting. It bunts the AST, which then you'd have to go compile if you wanted to insert in something here. So this gives you the bunt of a mold for a cell of A and B on pat. You can actually use a similar one in AX to build, given a spec, build an AST. That would be, let me find my, oops. Let's see. So this gives us a whole big, yeah. So there's a Barcol, Ketzig, Ketless. Anyway, so this is actually building the factory mold gate as an AST is what comes out of this. So there's some interesting pieces that get tied up in this here. We
I
can,
think for the base runes, like there's a difference between spore, which is like the default sample of the mold. So it's like it has the shape of like the bunt, or like it has the noun of the bunt, but it has no type information. Um, and I think for like the base runes, there might be a difference between example and spore. But I think what ends up happening for uh like more complicated runes is it will use I think the example comes from like the Mick of like, like using like sort of like the factory to like analyze the noun against the spore.
mhm. This is an example of how skips get parsed in limbs. So you end up getting a value back here. I guess that's aligned. That's why that's there. I don't know why it's a term. This is basically the number of skips that you need to do going back up your depth first search tree on this. Ted, do you know why this is a unit on the label in a limb search?
Yeah, which case is this?
This is the case where we've done a ket skip. And so the first number keeps track of the number of skips you need to do, but what I don't know is why the term is a unit.
It'll wipe off a face for you. I think
Yeah, you're right.
if you use com,
You use com dot. Yeah, yeah, you're right, Christian.
Wait, so if I do,
yeah, com dot foo, like if you have foo, com dot foo is
where would I
com dot
ket?
foo tis 3. Try that. All right. Com dot foo tis
Com
3 should just give 3.
dot foot is 3.
All right,
no,
sorry.
like this is for like the wing notation.
No, sorry, you have to do com dot something where
I mean, this did wipe
but
Like
it's
out.
just
com dot like com
the
dot
name.
foo.
do do Tisla foo Tesla foo bar
Yeah,
tis 3.
this does strip the name.
Com dot strips the face off of something, but right now foo doesn't have a face on. So try com dot foo, but do tis less foo to be bar tis 3. I think you have to do tis less foo tis bar tis 3. You can do tis faz there if you do it that way.
Oh,
You don't. You can also just run this.
there we
instead
go.
of-
There we go. There we go. Well, I want to see the AST
All right.
because
But I
I'm,
think also
I'm
like
curious about the
it's-
wing resolution here.
if you
Yeah.
run it, it should just print 3 instead of like bar tis 3.
Oh, because the COM would
There's
strip the bar. You'd resolve within the foo, and then the bar gets stripped by the COM.
Exactly. Yeah.
there's a similar thing.
But how is this different from spec mode? Like we use COM to
It's just
switch
not in-
into
This
spec
is not in
mode.
spec mode though.
Right, but we use COM to switch which way we're taking a value. Is that just because this isn't a
Yeah, but not com
Gateway
dot.
system.
Com dot is special
It's
syntax.
being parsed as a rope.
okay?
So it's
Yeah.
like when you're in a sort of rope parser. There's a analogous thing in skin positions, which is like ket tis fas, tis ket. That kind of does the same thing, except instead it strips it boils down to the skin that's like a sen wash, and it's like a sen wash of like a certain depth, and I think it's just like a depth of 0, maybe 1. And that will like strip the face from like what you're like tis fossing, like the topmost face.
Mm-hmm. Okay. I like this one. I like what we're seeing here, the way that it's hanging on to different parts of the name and the wing and everything here, and resolving that. Let's see, a moment ago I was talking about how dot versus col resolution. So there's, if we zap com tarhoon some value, this resolves to an A, or excuse me, to a wing search path. If I do the same thing, but I resolve it as a col, then you see that it resolves as 2 statements. So that's the subtle difference in this, is we end up with 2 different ways of resolving what ostensibly is a pretty similar statement. It also implies that you're probably going to end up with a simpler expression using dots, if you can use dots to resolve everything. Obviously, not everything exposes a face or a label that you can do a dot with, but if you can, it seems like that's a better use pattern.
Yeah, well, the
here.
big difference is that if you a col is just a backward tisgar, right? So it's irregular syntax for tisgal, which is backward tisgar, which is knock 7, right? So so with a col, you're composing formulas. You're executing 2 knock formulas in a row. Now, if both of those formulas are knock 0s, right? Because they're like leg lookup, right? You're looking up a limb from the subject. Then you're better off using a dot between them, because what that'll do is it'll compile to a single wing that's a single knock 0. Right, that just looks goes down into one part of the subject and then goes down to another limb within that. But that's one it's one knock operation. So that's more legible to like the runtime, right? That to the knock runtime. So it's better knock that comes out.
I seem to recall you mentioning at some point that the compiler was smart enough to see that a knock 7 of 2 zeros in a row would get optimized.
I think it's one of the few optimizations that the Hoon compiler has, at least in some situations I've seen it
resolve
optimized.
this? Would that be smart enough to resolve that kind of situation here?
I don't know. Try it. Try zapped his, zapped his of B col A instead of zapgar to tarhoon to B col
Well,
A.
I don't have any.
Tisfaz A to B is 42, and then zapped his B col A.
I could see that happening. Like another interesting case like that.
Yeah, so it does optimize.
Yeah, so it's okay. So it is smart enough here. So actually, in that case, it doesn't matter which way we write it.
Believe it or not, like Tisless compiles to autocons, and then there's like some analysis later that turns it like from like a autocons of like the new value in like O1 to like a knock 8.
Oh, really? That's interesting. Yeah, that's probably because, man, that's probably for historical reasons. I bet that could be cleaned up, but I haven't looked at the code.
I mean, as has been pointed out, not a lot of effort has been made into optimizing the knock compiler as opposed to just running knock faster. This is starting to.
Hoon is not an optimizing compiler, right? So most production compilers are optimizing compilers, where they take the code that you write and then they transform it in sort of complex ways. They do all these different passes on the code to output fast, resulting code, which would be in this case like optimizing the knock, right? Like outputting different knock. Hoon doesn't do that. This is a rare exception where the Hoon compiler has has this optimization, but in general, the Hoon compiler does not have optimizations and it is not an optimizing compiler. And it outputs something that's a direct translation from Hoon into knock. So it's very different from most compilers.
Well, this is a fairly transparent.
It is, yeah. This is it's a tiny, tiny optimization.
Yeah. We end up with knock 0 and knock 7 here. This sort of gets down towards things like the difference between knock 7, but the difference between arms and legs, right? So everything gets called a limb, and we worry about these wings, which are these limb resolution paths. And then, in Hoon school and some other, the docs very early on, we make this distinction between legs as data and arms. And then we talk an awful lot about arms, and we don't talk a whole lot about legs. Like, we don't bother to call values legs. And so the sort of the shorthand for this is a leg is a noun that's accessible through a knock 0 where you are. Whereas an arm would require a knock 9. Like this is fundamentally why we distinguish these two concepts. And so a leg would be something like a tizless or a tizfaz, where you're pinning some value in your subject. And then an arm would be something that's more explicitly called out. So you can imagine making a value available in both these ways, where there's a tizfaz or a lus, and it's resulting in the same value, but the way they're going to be dereferenced by the compiler as limbs is different. So there's also some slightly different behavior with arm labels as well. So arms are going to make a difference here too. So there's somewhere, it might have been in my notes from last week, but somewhere there's when the compiler is actually building this and it's dereferencing the limb, this might be in rope. It's going to try a knock 0 lookup, and then it's going to try a knock 9 to see how each one of those comes up. Now, this is where we get to the difference between a face and an arm name, which is that if we do something like let's see, let's Tizgar, let's make a core here with a buck arm, and increment 100. So that's just a regular .less. And then if I invoke the buck arm, this is the standard way I would do this, is I would invoke the buck arm, then it results in this value. Whereas if I were to do the same operation, lus buck .lus 100 hep, and I was referred to lus2 in my current subject, then I get the noun formula back. So if you retrieve an arm, arms only get executed by name. If you retrieve them by arc or by axis or lark syntax, then they get treated as raw nouns, which is an interesting distinction here. So this gets into how faces are not, faces and arm labels are not the same thing. Now, that's not to say we couldn't, pull the raw noun and we have the knock, and then we could execute the knock using .tar, but that would be kind of like black arts territory. I don't really know why we would do that. Outside of, for instance, the compiler, especially when we have vase mode and the other things we talked about last week. All right, let's see. Let's look at structure mode sum as well, which we were hinting at there a minute ago. So if I do A tis pat, B tis pat, this resolves to a coal-tar of 2 ket tises. Let me increase my size slightly here so we can see that. All right, so this results to a coal-tar of 2 ket tises. And then to get into structure mode, I kind of have 2 options. So one is I can write it with the com in front, which kicks it into structure mode. The other is I can write it with a buck coal that way. And in the second case, I end up with something much more complicated, which is doing this whole specification about what it expects in terms of buck runes inside of this buck tis and so
I think it's because it basically generates a buck coal inside of a buck coal. Like you'd probably want to remove the outside Kellenker, or like the sort of the Kellenker there.
I could comment too, see if that gives me a cleaner one. Yeah, that gives me 1 buck coal instead of this was doing 2, wasn't it?
Right.
Yeah, this was giving me 2
Yeah,
buck coals.
I was saying to remove the Kellenker, but that also works.
Yeah, and I mean, roundabout, we come to something that is sort of functionally the same thing here. In those regards, yeah, I guess this actually takes a list. Yeah, you're right. So if I remove this, then I end up with the same statement there that I would have had in the other case. So yeah, so leading com switches us back and forth. In practice, we don't do this a whole lot. There are some places in thread specifications, for instance, thread boilerplate, where this turns up and you end up wanting to toggle. You can do some interesting things with no, actually, that's not a good example. I was going to say we can mold using cells, but I think that happens automatically if I try to invoke. No, okay, no, I do have to explicitly kick it into structure mode for that to work. So then that's using factory to go build me a mold. Factory X is the one that we were looking at a minute ago here from that. So that's what the com is doing for us there. One of the interesting things is that what we're getting out of spec mode is, all right, so let me do pat as my spec mode here. So if I type spear into that, I'm getting a core, and I can resolve down and find that it has a buck arm and everything if I want to go dig around in the type. But this doesn't do the thing where it gives me a hold. So remember what we were always running into before with add and so forth is it would give us a hold, or this, like some things would give us a fork and so forth. Going straight into spec mode directly gives me a mold, an executable mold right off the bat. Let's see, I've got some.
Like when we resolve like an arm in the subject, why do we get a hold, and why when we do like spec mode do we get a core?
Is that
Like for that
a question or a statement?
It's a question.
So when you're
it's because it has to do with the name. Yeah, go ahead, Christian.
Yes, so basically it's like basically all name resolutions kind of get boiled down into centers. I maybe not always, but I think always actually. And like it'll get like um, but like if you're not like actually doing any like sort of like knock tens or something like that. But if the wing that you're evaluating is like the foremost is an arm, um like in either case what it'll do is it'll call ergo, which is like that thing in the less et core, which is like a subcore of mint. And what that will do is if the result of find that it gets passed signals that the thing that you're evaluating is an arm, what it will do is it will call fire. And what fire does is it takes that core. What you end up getting from find is like a pair of the core and then like the hoon of the arm itself. And then it'll construct a hold with the core as the subject, and the hoon as hoon of the arm as like the hoon to execute against it. And that's I think the only place that holds appear in the compiler is when you are basically like the result of a find like hits an arm, and it constructs a hold from there.
Well, and remember that mint returns a three tuple that is, you know, it's this this compiled, it's this battery, so it's the battery, and then it's a default sample, and then a tail to resolve the context inside of that. So you're also sort of building this thing in this context that then you have to still take care of. Have I swapped in the sample before I slam this gate, for instance? Like
Yeah, that's the part. What I was saying with like when it calls ergo, it's like epla and then some other thing if it's like for play, and then something else for more. But ergo is the one for like just like dry normal. What that'll do is it'll like switch all the values, and but then it has like two patterns. One is if it's like a wing resolution that is like Lark syntax, or like that's a leg, or it's one that's a core. In both cases, or that's an arm. In both cases, it'll like swap all the values, and the difference is that at the end, it will like call fire and like generate that hold if it's an arm. Otherwise, it won't. And like that swapping of the sample is that like like what swapping the sample ends up boiling into is like a sentence buck, and then like one of the things being changed is like lusgar, which is like the or lusgal, which is like the like position of the sample. And so that sentence will get boiled into like this call to ergo that will like switch the values there and then call fire. And like fire does like sanity checks on like the sample to make sure that like the sample you plugged in nests. If it's wet, it will call redo, which is like this whole thing where it like patches up the two different the formal type and the real type, and hopefully you get something that makes sense.
Yeah, here's it's doing the dryness and wetness checks on this.
And so this process of like trying it and like plugging it in, plugging in the sample, this doesn't need to happen for like when we're in spec mode or we're building a mold there. Sorry if I'm asking like a
we're
stupid...
not pulling it. We're not pulling it in as via a knock 9. Like it's sort of like the noun is present to us here. So like if I, like here's constant, right? So this is a builder right here. It it trivially results in a core.
Mm-hmm.
There's not a name and a core namespace and everything that I have to look this up inside of. Like this just is this is the core.
Right, like that. When you're constructing a mold, like what that ends up like sort of desugaring into, like after the calls to acts and so on, is like, like a tislus of like the spore, which is like the like basically like the bunt, but without type information, like, and then like a bar sen with like a lus buck, like like just like a trap, right? Because like tis less plus a trap is a gate, and
Yeah.
so like that's what that boils down into, and so you're like returning a core directly. Whereas in like that add case, what that boils down to is like a sentence but without any modifications. That is like resolving like the add arm in the subject. Um, and so like what's being fired is like the hoon which constructs the add gate against like the like layer 0 core of the hoon compiler.
Okay.
Yeah,
I think I follow.
Yeah. I think
Thank
comparing
you.
it to Bardot is actually like to a trap is a good move here.
Yeah, because this resolution makes a lot of sense to me. It's like, okay, yeah, we get the core out. But yeah, I guess when you're actually referring to something that's in the subject, that is why you then need to hold it instead.
Well, and in
Something
all,
like that. I can get clarification later. I don't mean to be taking up all the
Yeah.
oxygen with this question.
well, this is what we're doing in Core Academy. Like we're digging around in this stuff. I mean, a core name also doesn't resolve against your current subject the way like this right here. What is the context of this value?
Yeah, I guess I don't even think that this needs a subject, right? Like this could
Like
just
this is
be
well, it's where
raw.
I am, right? Like it's so I when I resolve it, I can write something like this, and it resolves where it is,
Right.
but it doesn't need to carry it doesn't need to resolve adjacent information the way that add does, for instance, right? Like add or sub or something may have to be aware of other things in its own core.
Well, I mean,
Right. Okay.
it does. I mean, because like when you like construct like what the bar dot will then like desugar to is like a bar sign with like one arm named like called buck, and so like when you do like evaluate that, what you'll end up with is like a core type, but then like the subject that the core was like defined against is going to appear in that core type, right?
Right.
It's but in the add case, it's like so like that core is already defined. It's already in our subject, and the resolution to that, like the route to resolving that is firing the add arm, which is effectively like something that builds a core against like the core of layer 0 as the subject.
Let me show you like a different example that might help figure this out. I guess that's libtiny. So there's a libtiny in the base desk, and it's used for the naive rollup smart contract stuff, and they use it in Aries development stuff too. And so when you Wetgar a statement, your resolution takes place against the subject that is specified by the Wetgar. Right.
Yeah.
So if I refer to something that isn't in there, like there is no RS. Like Tiny is a minimalist implementation of Hoon. It doesn't have all of Hoon in it.
Right.
Like it doesn't have the whole standard library. I mean, I guess it has Hoon because Hoon, anyway, it defines like this minimalist representation. And so even though this is recognized in the broader context, I could write this, it cannot be resolved within the constrained subject that it's handed here. So a lot of this comes down to what is the subject, what is the context against which the subject being, your sample and your context against which I'm resolving this formula that I end up with.
And so in those cases, you need a hold. Like that's like the main thing I'm trying to get at is like the hold versus the core, like when those gets resolved in those particular ways. I guess like when you ask add, like just in Dojo, that will like that will resolve to the add, or that will resolve to a hold instead of a core, like the like what we did in structure mode, because it needs extra context. Like I guess if you generally just do
it's a name resolution, right? So it's like if you have a name resolution and the name resolution boils down to an arm, notably where like your wing, like your arm is the foremost limb in the wing, right?
Right. I think I
if
finally
it's
understand
anywhere
it
else,
now.
it refers to the whole core. Yeah, and so you only build like the whole type when a name, like the foremost limb in a wing, is an arm, and that hold is just like the Hoon code of that arm against like the core itself as the subject. And so it's through name resolution, like, and it's like if it's an arm, then the hold gets constructed, but only in that case.
So bigger, I mean, we're running into these with arm names because of, as Christian said, the name resolution issue. But what a hold is doing is it's basically telling Hoon, be lazy about evaluating a thing. And so for instance, in this example here, a list type results in a hold. And this is related to the fact that Hoon doesn't know naively how long this list is. We run into the what sig and all that junk with it. And so a hold, one way of putting what happens with a hold is when you evaluate a hold, you're sort of telling the compiler to play the Hoon against the subject and then tell me the thing that I'm getting back on the other end. Right. So if I evaluate, if I were to set up and slam a vase of this type against a vase of the subject, then I could resolve this down to, well, I know my first value in this is a concrete pat UD, and so my head is a value, and my tail is another hold. Does that make sense?
Yeah. I think the whole piece that Christian explained with the particularly like the name resolution of this, because when you're in spec one, you're just like dumping one of these things out. There's no name, right? I'm sure that if we put that in a core and then we tried to resolve the name in that core, we would get also a hold. Is what I imagine anyway.
Yeah. Did you see?
Yeah. In the list case.
Go ahead.
Oh, sorry. Go ahead.
In like the list case, like the hold there, like because if you look at like the mold builder, like it ends up calling list again, and so like what you end up getting there is like you basically like you play the hold once, and then what you would end up with is like a fork of like a sig as like a sort of like raw constant, or a cell with like I as like the value of the list, and then T as like, and then the hold will appear there again. And the hold there I think would basically be like the code that generates the bunt.
Yeah. Okay. Yeah. So in that case, you need it because you're continue to resolve in this sort of like recursive way, and you can't do it all at once.
Right. And notably, like the hold comes from the fact that it's like calling list again with like the same item type, right? So like you have like like your hold there would be like, like a like, sort of like evaluate the buck arm. It might be like several layers of holds, because it would be like a hold around the call to like the list mold builder, and then and then like within that hold, like if you play that hold, then like you would wind up with then like a call to the buck arm of like the list builder, or of the generated mold.
Mhm.
I think is like
So
what you would wind up with
Hold
there.
up. Hold up. What the heck is structure and spec mode? Like, I haven't heard of this stuff for years, and I
what
don't.
is structure mode? Structure mode
Yeah.
means you're in buck runes.
Okay.
It's just like this is what a spec is in a sample.
Yeah, and so
Oh,
if you have like a
so
lust
there's
buck
only
and a
structure
core,
mode
that's
versus
spec mode.
non-structure mode.
Yeah, lust buck, yeah, value mode and structure mode are the two modes.
Okay.
But
Yeah.
if you're
Like when
specifying
you're
a
constructing a
type,
sample,
you're using structure mode.
yeah, like in
But
Bartiz, you're making structures as well.
Yeah.
There's like one other thing, in addition, there's like skin mode, but like let's not talk about that.
yeah.
What's a structure?
Well, structure is a structure mode means you're specifying a rule to determine whether or not a noun nests.
Nests. Okay.
And that gets back to the compiler stuff from last week. No, I want to show you this example of holds because I think this illuminates a little bit what's going on with holds too.
But how can you use com? What's the com have to do with
Com
it?
just switches you into structure mode if you're not in structure mode.
Okay, so basically the buck rune's already a structure mode.
Yeah, if
And
you're using the
com
buck
can
rules, you're
switch
in
you in.
structure mode.
Com's like a
Otherwise-
shortcut for defining a structure real quick.
Yeah, so like if you want to define a type, but you're not in a place where you would naturally be defining a type and you don't want to use a buck rune, use a
I
com
see.
to toggle.
I see. Okay,
And it's
thanks.
actually a toggle. So you can go into value mode if you're already in structure mode.
Oh, and so it's just anywhere in your Hoon, you can just toggle it and it's on? Or does it wait
Well, it'll
for
toggle
a
it
structure
for
to
the next,
define?
it toggles it for the next expression.
Okay, so you com and then the definition of a structure and then it's off.
So I want to show you this one because this one illustrates part of what's going on with the holds. So a regular list or a homogenized list, the system is making no assertion about, or basically the system is making an assertion about the type, that it has either homogenized the type or it has enforced the type structurally through actually ultimately a ketless. A limo, on the other hand, it's actually not asserting type, it's just asserting that this is a list shaped thing. And so you have this what it's saying is I have these as yet unresolved types in my iterator that I have not yet, I have a hold sitting on top of these. This is the pretty printer's way of showing us that we haven't resolved these values yet. Now, in
What would
practice,
happen if you casted what happens if you cast the argument to limo to a list?
so if I cast this first, like that.
Yeah.
It looks like it actually doesn't even, it looks like it's still holding off. And it's an interesting
This is
result.
so weird.
There's another.
What would happen if you added a fourth?
Well, let me
parameter?
show you one more, which is the lie list builder, which we almost never use. This is one I was asking Tennis about in Hooniverse the other day. So you see this type there? The type is crash.
What is
So
the
it's-
intended use of this? Of
Yeah,
lie?
it's not used anywhere.
Because I know that there are like
Um,
there are equivalents for sets and maps, which I feel like I've used like ages ago. I used it. I don't know if it's like good practice to use it, but
Yeah, my and Malt are the map builders. There's a subtle difference in them, and I always forget which one is actually recommended. I think Malt and Silt, Malt for maps and Silt for sets, is the recommended ones, and it's because Lie, My, Psi are from raw nouns instead, and so this is actually the crash type in them. Wonder if yeah, actually it didn't just crash, it expected fork to be core, which is kind of an odd one
Okay,
there.
if you want to go in Hoon deep lore mode, then try, you know how in like Python you can do x comma y comma z equals 1 comma 2 comma
Oh
3?
yeah, like
You can do that in
tuples.
Hoon.
Yeah, with the Tislas.
Yeah, how do you do that again?
I think you give it the faces. It's something like you give it the faces and then you give it the addresses that it resolves against.
But
what
It's
in the world?
it's something like that. It's a weird,
What
it's
It
not
is
obviously
there.
that failed, but it's
fully
something very,
undocumented.
What's
yeah, it's
the
an,
Python
it might be
concept you're
PIM, it
Okay,
might
it's
be
referencing?
just
like
like
this.
it's called like variable what is it
It's
called?
it's tuple assignment.
Yeah, tuple assignment. When it's
Oh,
like x, y, z equals 1, 2, 3, and you get x equals 1,
just
y equals 2.
remove the PAM2 and the PAM3, and then
No, but there's a
replace
way
the
to do it by numeric address.
But let's just check the first to the regular non-address thing first. No, it's not it. I saw it today, but the chat was
Okay,
ephemeral.
this one will do. There's a way to do it
Okay,
with
okay,
numeric addresses too,
that's
inside
not
of a
bad.
larger noun. And it's actually a really clean way to unpack when you have multiple return values.
Yeah, tuple unpacking.
I don't see it used
could
very
you
often.
could you write the Python example?
The
It's
Python
just,
example
yeah,
would look like
I do it in the chat.
A comma B comma C equals 1 comma 2 comma 3. And you get simultaneous assignment of A to 1, B to 2, C to 3.
Doctor, what's the context here? I'm lost. What are we doing?
We're kind of down in the weeds right now on the compiler and stuff. Okay, but let's go back to let's go back to cores, but not the we'll look at core definitions here. So not the I guess there's a double per in there. I want to look at like what actually happens when we define a core. So not a hold. So like when we have a core, we're not worrying about a hold. We're not worrying about a happy name resolution name. We're worrying about we actually have a core. What is it? What does it mean to have a core? And so the way that Hoon formally does this is it specifies information about the behavior of the various components here. And so internally it calls this like a var and some other kinds of things. So I already unwrapped everything and laid it out here. So ultimately, these two lines here, the wetness, dryness, and the variance model are describing the way in which cores can, to some extent, the way they're treated and the way they interact with other cores is what's being handled there. This stuff here, where we're actually keeping track of the terms and the Hoon they correspond to. This is like how we compile arms. So we have like a table of arm names, and the hoon that corresponds to these arm names, and as an AST, that's what the hoon is there. In the current compiler with the semi-nouns and everything, this is actually incredibly complicated because of dot chords. But sort of simply, if we weren't worrying about dot chords, if we were worrying about like old school chords, this is what we'd be saying. We'd be saying, here's a list of arm names that are lookups in this map, and they point us to information about what's going on with, like what is the hoon that corresponds to this. I want to talk a little bit about core variance and wetness and everything, because this will come up as we look at compiling things. So you've probably run into wet gates before, at least informally, in the way, in the sense of like there's a bar tar somewhere. And you'll notice that, yeah, actually we probably could just remove dot chords, and that may be the ultimate fate of them. So a normal dry gate, yeah, there is, we talked about the master on-off switch last time. If you take a look at the docs, it's in Vang for turning that stuff on, off and on. But it's not, you can't turn it off and on when you initially boot your ship for the first time, which is a little bit of a pain. All right, so regular dry gate basically enforces the sample directly on the quantities. Like the sample demands certain things, and it enforces the type on the quantities when they come into that hoon expression. And so in a sense, you lose type information when you run a dry gate on a value. A wet gate is more flexible in that it gets described as a macro because it basically at runtime resolves whether or not the noun that you're handing it there works. It feels a little bit more like dynamic typing. And so, for instance, a lot of the list functions, the list gates, are built as wet gates because you can hand it like a list of pat UX, and it'll snag a value for you, and it'll give you a value back, and the value will be a pat UX. You didn't lose type information when you threw something into a wet gate.
It is compile time, not runtime.
It's compile time. What did I say? How did I say it when I said it?
Runtime, resolves at runtime.
Okay, what I mean is that yeah, it is compile time, but what I mean by that is that we're saying if the core had been compiled using the supplied sample instead of the reference sample, would it still result in the same knock? That's what a wet gate is allowing you.
It's like
back and unpack.
Look at fire. It will call redo. So it's not exactly like the subject it was compiled against, or like that you swapped it for.
This is where yeah, right here.
Yeah, so you see in like the case that it's like a dry call, it just reconstructs the core with like the original type, but it makes an assertion that the modified type nests under the formal type.
Yeah.
Whereas in the wet case, it'll call redo, which basically just like does some like screwed up magic to like patch up the modified type with the formal type to make sure it has like the faces it's supposed to have and so forth.
Yeah. The way you can think of it is a wet gate is asking, I don't want to say it quite this strongly, but this is kind of the sense. The wet gate is kind of saying if we ignore hoon type rules for this case, do we still end up at the same knock? that we would have otherwise. Because type is a Hoon convention. And so wetness is letting us relax that Hoon convention so that we don't end up losing type information by coercing it when it comes into the gate in the first place.
And it's like when it's like constructing the hold. So like so like in the case of like, I don't know, turn or something like that, it'll be you're constructing a hold where like the list and the gate that you plug into turn are like more specific types than like what it is by default and as the bunt and yeah, like that's kind of where you can like with that's where you also notice that like frequently you'll need to like actually like cast your types because like it'll otherwise redo is kind of bad at like reassigning bases that it should have and so that's why like frequently you'll need to like cast to like a list or like a map or something rather than just like supplying the values raw.
Yeah, so like turn, I think turn may be an example. I know, no, okay, turn doesn't, roll does. For instance, roll and reel do. So roll would, roll will fail without the type information, and it fails on a mole grow because it's failing on the wetness. It needs to know that this is a list to resolve that successfully. Is an example of that there. So dryness and wetness then has to do with the nature of the knock the knock formula that results from what you're doing with the Hoon types. The core variance is explicitly a system of which parts of your sample, your battery, your payload, all this stuff are readable and writable to things that are interacting with them. And so we have this convention where we're assigning them a variance by metal, but what actually gets resolved is when these are called in places like Deem, it's passing in quantities read and write on different pieces of this to basically, let you say, can you, are you permitted to do the kind of operation that you're talking about doing here?
Yeah,
so,
and you also see, I think in like take and which is like swap a value and like it's basically not 10, and then find as well.
See it in take.
Or it might not be in take. It might be in like toss, maybe like toss and tack.
TAC has write, so it's probably pulling in that information one way.
Yeah,
it's anywhere we run into like read or write, this is what it's doing, is it's setting these permissions to get a certain behavior. Actually, what's kind of neat is let's look briefly at how a bartiz is constructed. There's a bartiz. So this is where it's basically desugared into a bar cab so it's the door, and then it inserts in the buck arm reverse composed with p.gen. So that's how it's inserting the buck arm around the Hoon that is supplied to the bartiz in the AST. Bar tar is doing something different, but it's doing it through bar pat instead of bar cab. So bar cab is a dry door, bar pat is a wet door. And so that'll give you a little bit different treatment when it actually finally runs down into those. I think bar pat might be primitive actually and doesn't have any desugaring. This must be an open AP. Yeah, I'm an open. anyway, just kind of a curious piece of how these things are getting constructed. Okay. Another thing, let's see, what else do we need to know how to resolve besides these names? Oh, we have other names, right? Right, so we have names that are actually dynamic names. So every time I refer to entropy, every time I refer to now, I am getting a new quantity. Okay, so what is this, right? Like what is actually happening when I refer to this? So let me zap tis. First off, let me zap tis hour and see what I get there. Oh, so hour actually resolves to a direct subject lookup. Like there's an slot in our subject that we are hitting this value with. What is OPE, Matt?
Zaptizing our very Midwestern.
Why is that Midwestern?
Ope.
What?
You don't know Ope?
I don't know what
Okay.
OPE is.
Yeah.
That's why I asked.
I'm from Ohio, and I'm Midwestern, and I don't know what oat means. Maybe that's like one of the weird sort of like Fargo
It's like,
dialect.
just squeezing past you.
Okay.
Sorry about that.
Did I say OPE?
Yeah.
Oh, okay. I guess I just do. I don't even notice it. Anyway, we're
Ted's
resolving
gone.
an
I'm allowed to be
axis.
retarded.
We're resolving an axis in our subject every time we do this. This is simply supplied by Arvo, from the runtime. Like this just is that quantity. And so anyway, there's the values there. Let's see. I've got some Kelvin versioning stuff. Let's take a look at dynamic dispatch. All right, so static dispatch is what you're used to in Hoon. This is regular Hoon. So this is a compile time. When I know at compile time, what code will be executed when I refer to a name. Dynamic dispatch is interesting because in a language like Hoon, this is basically saying, how do I do runtime resolution of a name in a language like Hoon? It's kind of an interesting problem. And if you're trying to do this like in a Gall agent, you can have some difficulties, but with vase mode, we can do this. And so Dojo, for instance, does this every time I type a value. Dojo has to resolve this dynamically at runtime. So if I go to app and I find dojo.hoon, this was in, let me just search. Slam, is this the right spot? Yeah, so dy done. This is where you're actually submitting text tape to Dojo to run a value. You're saying, Dojo, run this value for me. And what ultimately happens is it's going to slam this against the current subject that it's constructed in putting all these values together here. And so the way that we get dynamic dispatch in Hoon is through the vase algebra. So we can get runtime dispatch, we can get an interactive interface. But what we're doing on the back end is we have to slam what we've done with our vases to actually result in either modifying our type or whatever the thing is that we're doing with our type and those with our value and then our type in the type of subject sense is what I mean there. All right. Any questions about dynamic dispatch? There's a sense in which this is kind of straightforward because, okay, we just have to slam a value against our current subject. Can be a little bit hard to end up at if you're thinking about it from first principles, but it works once you actually have slam and slap algebra. setup for you. Kelvin. All right. Let's look at hoon.hoon. What happens when we actually run hoon.hoon? So first off, we have a very interesting problem, which is that we are going to have to compile hoon.hoon. And we sort of glossed over that last time. We said, okay, we're building Hoon. Hoon does certain things for us. It has a compiler, it has a parser. But what we're actually doing when we generate Hoon is we are tizgal, so we are evaluating ride after defining a subject. And so Hoon will be the subject for this execution of ride, and then the result of that will be the subject for whatever is subsequently executed by Arvo. So the innermost core of Hoon is kind of phrased with these tizgars in this roundabout way, but it basically resolves to this. It's the version stub. This is the piece that, well, we are visiting first principles, right? This is what we're doing. Or are you talking about in the PR sense? I don't know what you mean by enumerate the first principles.
I'm just saying.
Like so like here, this is the innermost part of Hoon, right? If I refer to anything in the middle of Hoon, the core of Hoon is actually the Kelvin version, right? This is the thing that we've defined here. And we're going to sig sen it as a tag because this is what the runtime is going to be looking up, right? Like you've definitely run into upgrades that are blocked on your runtime not supporting the current Kelvin and so forth. That's what this sig sen is signaling here, that it's passing this out as a hint to the runtime, so it actually has this root here. But this is the beginning. You'll remember that other sig sens that we look at, they always resolve against a subject, like add, ride. Sigfaz elides that, but sigsen always does this. Here we don't. Here, like, we have no subject. We are the subject. We're defining this at the innermost part here. So when we talk about Kelvin versioning, before we get to more about hoon.hoon, we actually have a few different parts of the system that are subject to Kelvin versioning. And so if I list them in order here, I've got Nock, I've got Hoon, I've got Arvo, I've got Lol, and I've got Zeus. Now, what do you notice about the numbers of these quantities here?
They're ascending.
They're ascending, right? If you've read, there's a fairly old blog post now about telescoping kelvins. This is back in the heyday of the FazWhat rune, when you would see a lot of core code that had a FazWhat and then some version pinned like that at the top of the file. There's still a few files that have this, but for right now that infrastructure has been ripped out. This was a version pin, and it was basically saying, well, this file won't work unless we're at this Kelvin. And it was sort of ambiguous. Do we mean above this Kelvin, below this Kelvin? What do we actually mean by that? And telescoping kelvins means that if a tool sits on top of a platform, either the tool and the platform must be at absolute zero together, or the tool must be warmer than the platform. So we cannot actually say that Arvo, which depends on Hoon, is cooler than Hoon in the rules of telescoping kelvins. This also means that if you are ever going to introduce a tool which you feel should be Kelvin versioned, it must have a higher Kelvin temperature than whatever part of the platform that it relies on. If it relies on Arvo but not on Zeus or Lol, then you could put it at 300 Kelvin. But you have to build it higher than whatever that temperature is. Preferably you want to do it a fair bit above, because you're going to want a nice thick onion ring around whatever you're building, right? So you have lots of room to resolve that before you end up at whatever your eternal specification looks like. Not every part of base is subject to Kelvin versioning. It really is defined by the things we see as platform. The language, the event handler, and the standard library are basically the things that we're saying at this point should be subject to that. At one point, there was a theory that we were going to like sum these and pin these to the sum of the parts that were lower than it, but I think that kind of got messy and backed off on there. Given, let's see, let's go back to hoon.hoon. Given the fact that this is layer 0, this is the innermost part of our hoon, if we refer to other things in hoon, then we have other, yeah, so this is referred to as layer 1. It is sig sen with 1. The sig sen will be significant because when we jet these things, as we would have looked at a couple of lessons ago, we have to refer to the core that they actually nest in when we identify this in tree.c and when we jet everything in our tables. Less bar sort of functionally doesn't do anything right now, but it's in there. Core 0 is arithmetic, or excuse me, core 0 is version stuff. Core 1 is your basic arithmetic, and hoon is written as a series of I guess hoon is 6 layers, and then Zeus Lol is a 7th layer around the outside of it. But it's a set of cores, and each core can refer to everything that's inside of it, but nothing that is outside of it. So add can refer to decrement, and it can refer to knock, but it can't refer to anything else that's not defined as a primitive here in terms of what's going on. Dec does not refer to anything that is not part of hoon as a language specification. It doesn't refer to any other names of things here. Leaf is only a head tag, right? Like it's not a value, and everything else in here is an absolute primitive of the language. Div, interestingly, is actually the head of division with remainder, getting the cell and returning that value back. And if you go read the actual code for all of these, which I commend to you at some point, there's actually some pretty interesting surprises in there, right? Like greater than or equal to is not less than. That's sort of the simplest way that was suggested to have been written there, for instance. Core 1, I could run down and talk about, I have a lot of notes written that I'll share with you of like what these are doing. If we're thinking about it from a core developer standpoint, some things that are interesting are things like each. So each is a bar buck. So this is a mold builder. It's a mold generator. And this gives us the ability to discriminate between values on type using a flag. So there's going to be a flag at the head of this. So for instance, if we're getting structures out of a parser and we don't know which kind of structure we're doing, then we can actually use this head tag to decide, like if we're returning 2 kinds of lists, like a fish loop is the error that happens if we use a what tis. Like we can't discriminate 2 kinds of lists, but we can use a head tag here to do that sort of thing. So for instance, if I pass this in, then it'll attempt to coerce to one to the other, but it does let me distinguish these values from each other using that head tag. Christian points out that add using dec makes it on squared when it could have been written on without it. That's true. It could have, since it was going to be jetted. I suppose that just simply wasn't the objective there. I've run into some interesting cases. There's definitely sort of 2 schools of programmer. One of them, which I admittedly fall into, is the kind that sort of like actually likes to specify every case, even if that case is latent in the type. So, specifying that a value must be greater than or equal to 0, even if it's an unsigned type. If that brings it closer to the on paper written specification, I kind of feel like that's better, even if it's superfluous, because it's going to get cleaned out at compile time, versus just, letting the type and everything handle what's going on there. Layer 2. Yeah, unit logic. We actually, there's a lot of interesting things that you can do with units that we don't. There's a full algebra here of either modifying things or, like here, we're using wet gates again because we're not specifying what kind of thing the unit is. So like Biff takes a unit, so we'll say a tick 5, and it takes a gate. I guess deck, let's see if it's happy with that. Yeah. So Biff will apply a gate to a unit when the gate doesn't normally apply to a unit. And there's a whole bunch of these. There's like a bind and a fall and some others. Lift. It's kind of similar to what you get with functional programming when you look at Curry and all these other things, but it's designed specifically for use with units. And although they aren't used a whole lot, it's suggestive to me that there's probably some things we can do with them that would be more expressive.
I'm kind of surprised that compiles, because
Which one? This code?
The Biff that you just called, because it's expecting a gate that, because it's expecting a gate that returns a unit.
No, it's expecting a gate that returns a noun.
No, it
or
takes
that operates
a
on a
noun,
noun.
but it returns a unit.
Let me see how Biff is defined.
Well, it's like right there. It's right there. Like, see the buck hat tar unit?
Well, said it accepts something as a unit.
Well, yeah, but it says that it's expecting the type to return a unit, or like the gate to return a unit. Like, that's where the buck hep is. Like the B tis buck hep tar ace how unit. It's like the B argument. You see, I'm surprised that compiled.
Well, then we have like bind, which lets us attach a unit to something that didn't do a unit before. Yeah, so there's a lot of things we can do with this. Sid9 points out unit logic is super helpful when dealing with JSON unit parsing. It's useful when you're dealing with parsing, period, because parsing breaks in a lot of interesting ways that you run into with things. Then there's a ton of, list ops and binary ops and, bitwise operations and everything. Containers. Yeah, I'll give you my notes on this, but I don't like want to go through hoon.hoon. I've done it already this week. Jam is interesting. Okay, so what does jam do? What about terminal? Right, so jam, we give jam a value, and it's actually easier to look at it in the binary or the pat UX. What jam does is it uses, from starting at the least significant bit, it marks the cell or an atom with a 1 or a 0, and then it marks the bit length of the value and then the actual value. Okay, what are you sad about, Mopful? Not going through hoon.hoon line by line?
Yeah, exactly.
Well, it's kind of a monster file.
It is. We all have the book, right?
Yeah, you can have you can do the book. Honestly, and actually,
great bedtime story.
I mean, it'll knock you out. I find that I think Hoon and Zeus are probably due for a reorganization. I don't know if anyone like in our lifetime is going to have the energy to do it. But there's a lot of weird edges in there now that I think kind of need to be cleaned up. It's definitely a palimpsest of people writing code over a decade. Yeah, so what Jam is doing is it's trying to solve the problem of how do you serialize a noun, right? So you can take any noun and turn it into a value. And so what you'll notice here is that we have a 0 for this being an atom. We have a 1 for the length, and then there's a 0 at the front that is stripped off. Because, it's head trimmed because all zeros get head trimmed in Hoon. So 0 for atom, 0, 1 for length, 1 for value, and it just kind of moves along this way. Kind of an interesting exercise to actually sort of like sit down and look at how these are getting written out. The one thing that I do not understand with Jam, I've not been able to answer this to my satisfaction from reading Jam and Q yet, is how does it know how long to read the bit length? And I don't have a good answer to that yet. So functionally what's happening is 1 bit is the Celler atom, next entry is the bit length, and then the actual value, but I don't know how it decides where the division line between bit length and value is.
Have you looked at noun.py?
No, I haven't.
I'll
How
put
does-
it in this chat here, and you
how
can see
do-
how it does it. It does it through recursion. I just wrote noun.go and I
Okay, so
slept
you're
since
fresh
then.
on it. So how does it know what the length, the bit length of the value is?
I'm looking. It's been a bit. Give me
Okay.
a second. It does some weird in queuing. It does some weird exclusive. I think some weird or between 2 reads, and it gets it to you. If you look at that link and look at rub, I think that's how it does it. But that's a good point. It's not obvious to me.
Bits below, and then it left shifts a certain number of bits. Yeah, I'm curious because I was looking at like gzip and everything this week. And so now I'm kind of stuck on like, how do you actually tell how long this is? We ran into this problem with the original version of Lagoon, the linear algebra stuff too. Like, how do you actually tell when your length marker is done? How do you know when to stop reading it without some sort of convention? It's a hard problem. Yeah, functional programming combinators, type definition, blah, blah, blah. Okay. I'll give you notes. We'll skip over them. Let's go to, okay, great. Parsing compiler, that's huge. Okay, so layer 5 takes you out through the compiler. Layer 4 is, I believe, the parser, and layer 5 is the compiler. Something like that. Or maybe they're tangled up with each other. But then Hoon is the root of the entire system. So like with tiny.hoon, what we were doing was we were compiling a version of Hoon and then using that as the subject. And so Hoon being the root of the entire system, everything we do is sorry, I'm distracted by the chat. Length is unary, so it's just like spamming ones until we get a value. Is that what's going on? Might be.
Yeah, that's actually what it does. If you look at rub, it says while not 1, your z just gets incremented. So
So as long as you're getting ones and then you have a byte of zeros or something after it to
Yeah.
break.
yeah,
Okay. Interesting.
I think you're right.
Well, that is a solution. It's not necessarily economical, but I guess that depends on how big a noun you want to send. So Hoon is the root of your system. And then there's LOL, which are kernel-wide structures. It's kind of like a header file that that everything else gets assessed against. And then there's Zeus, which is like the standard library that everything's done in. And Zeus is where like ordered maps and there's like some Q stuff. There's the formatting, the JSON, some of the HTML reading. Very interestingly, the headers for each of the veins are defined in Zeus. No, they're defined in LOL. So like if I want to actually look at the clay interface, and we'll come back to this when we talk about each of the veins in turn, we're actually going to start from these definitions, because these basically define what does this actually know how to operate on? What are all my kinds of things here? Tacos and yakis and all these funny things that you run into as soon as you get into clay.clay. They're not defined in clay or in clay.hoon. They're not defined in clay. They're defined in LOL because everything else in the system needs to know what they are in order to share them. And then there's a lot of Arvo definitions and everything that all gets sent there. Zeus has cryptography. It has quite the library of cryptography, for instance, besides a whole modular arithmetic thing. It's got, let's see, we've got, modular arithmetic. We've got elliptic curve cryptography stuff. We've got advanced encryption standards of various modes, AES3 or current AES SHA-3 is Kekkak. We've got Schnorr signatures, which are used in signing things. Schnorrs are used in Bitcoin, aren't they? In Bitcoin Merkle trees? I think so. Did we just lose
Taproot, yeah.
Oh, that's Taproot thing. Okay. Did we just lose half our screen? Can you see through that?
Yeah, the right half's all black.
I think this is.
I think somehow that was my fault.
Did you share something or?
No, it's like sort of like a draw on screen thing, sort of.
Oh,
like
we've run
popped
into
up,
that
and
before in like Hoon
clear.
School. Yeah, I don't know why it does that, but it blocks part of it. Yeah, a lot of cryptographic hash functions are all set up here that are going to be used in jail and other places, just so they're available here. Most of this stuff predates the Bitcoin wallet app, but it's compatible with it. So yeah, if you want to do basically any SHA or AES stuff, like odds are pretty good Urbit has some version of it here. A lot of text and JSON reparsing in Zeus. Let's see, this is LOL. So let me go back to Zeus. This is worth your time if you've dug around in this before. If you haven't dug around this before, let's see, is Joie here still? Did she drop off? I think she dropped off.
I think she dropped off.
Yeah. She had to dig around in this because of let me zoom out a little so we can maybe fit the comments. When she was writing John, which was generating John is a library that accepts an example of a JSON and produces a reparser for you for it. And remember her talking about having to dig around in this, but most of this is not actually documented. So there's a lot of different parsers in DJS that, unless you go dig around in DJS, you're not going to know they're here, basically.
It also has one of the
OJ.
most sort of
Object is jug.
it also has one of the more sort of most sort of tricky sort of things. I don't know, I like trying to figure out like in like type theory literature or whatever something here, but like of like use of wet gates where it's kind of like
Like
the
these
fact that
things.
like look at OT for example. Right. So yeah,
Where's
you're
OT?
providing a list of things, and then it like unwraps to like a static tuple. It's so because like if it was like sort of like if it did sort of a like parametric polymorphism, you would end up with like a union type, right?
Mhm.
In the tuple where like each tuple has like the same union type, but it doesn't do that. Um,
I also want to point out to everyone, if you've not been using polls, you should think about using polls. A poll is a list without faces. And sometimes that's actually really useful, like when you're doing scry, path matching, and so forth. So anywhere you see a poll, it's a list without faces. We stripped off the faces for some reason. Yeah, OT raw. Yeah, OT raw is doing the shovel work on this conversion here. I don't know what a fist is, so we're down in the weeds on that.
it's just like a JSON, something from like type of JSON to like anything else.
Okay.
It's just like another JSON parser. It's not like these are parser builders. Like a fist is a JSON parser.
The color sticks and stub. This is a little set of tools for doing colored text in Hoon. Obviously SigPam is doing this, but you can do full color operations and everything in Hoon. There's a tutorial, track 7, that walks you through how to actually produce stickses. So they end up being like these sorts of terrible statements like this, where you have to layer together various kinds of, like, this is bold text and then it has color and everything. Anyway, they get really nasty and complicated. But you can do some pretty cool, like, actual text styling at the CLI with them. It needs a better interface than Sticks, but Sticks is what we're stuck with for the time being there. Let's see. NJS, noun to JSON, DJS, reparsing. Oh, there's some diff tools for diffing values. So like loss takes 2 lists and produces a diff of 2 lists here. Yeah, Palfin's TUI stuff is good. The problem is that it's like already broken. In that
The stuff he presented at Volcano Summit.
What's that?
The stuff he presented at the Volcano Summit is already broken.
Yeah, it's already broken. They've changed something in Dill, and it doesn't, the lib e2e that he uses doesn't clear the screen after an update anymore. So you get like weird artifacts left over in the terminal. I don't know. Like we need a proper curses library. Like we need a proper library to handle those things. Anyway. Yeah, so diff gives you actual diffs between nouns. And it's one of the first places that the abet nested core pattern shows up, that we'll get into in a subsequent lesson when we go deeper into that. HTML parsing, there's some wire stuff, all the identity, like sign, title, all that is in there. User lib, which has pretty good UTC time statements. So dust chrono user lib your now gives you this kind of nice statement here. And it actually does pretty good going the other way. It's not full ISO standard implementation, but it does a pretty good job at guessing what you want. And I think it would not actually be very hard to extend it to parse arbitrary input dates. I don't know how picky it is about like whether it has, yeah, so it's pretty good. There's a libchronos library that I'm probably going to turn into just a proper date time library and bounty it out for someone to finish, but that could be built on a lot on this user libchronos stuff to make that happen. All right, we've talked about libtiny already, so I won't go over that. Oh, what I did want to look at too is the test thread. All right, so if you've run tests before, what you can do is you can give it a path by convention tests. And what it does is it pulls up the core there, and it pulls up every arm that has test in its name, and then it runs that arm, including against the subject that's defined by that whole core. Now it's interesting to say, like, okay, so this is a thread that is actively building a list of arms and then dynamically running each arm in isolation to produce results on whether or not the tests pass. So if we go to test.hoon, Strand.io is probably going to be doing some of our work here. But what we're actually going to resolve to, where does it find? Yeah, so get test arms. Where does it find? Okay, let's actually just start at find test files. So this is where we actually get the list of files that we've passed into test. So it's going to go ahead and it's going to do clay lookups. It's doing them indirectly because they're wrapped in Strand.io calls for cleanness in a sense. Getting everything that's the path at a particular tree. It's doing the loop convention here with the so that it loops back to this buck arm. That's probably an artifact because McGal used to introduce a spurious buck, and there are two McGals here. That's no longer the case, so we could probably get rid of that and just write a conventional buck here and not have to worry about it. So this is building our list of files. And then what's interesting is when we go through these cores, we're going to be turning over the arms that have the test prefix. So we're going to have this list of arms. So now the question is, where does a list of arms come from? This is what slow does for us. So slow, we'll take a look at slow in a minute. We give slow a core. It might just want the...
It needs to be a vase.
Oh, that's right. Okay. Yeah, because this is all...
Or maybe just the
Maybe
type.
it needs the head of the vase. Head of the vase. There we go. There we go. Head of the vase is slow. And now I'm actually curious if it would just... Yeah, so yeah, within add, it picks up just that there's a buck arm. But at the top here, it's picking up the name of every arm. And so slow is what actually gives us names when we're going to be resolving this. And so what test is doing is it's slowing those values, and then it knows to run everything that actually comes out in that test prefix. We could actually probably do a version of this with MERN instead of turn too. That might be a good exercise to do someday for someone. All right, so what slow is going to do is it's going to take a hold, a hint, and a core. And what it's doing is it's looking in that tome that was inside of our type, QRQ type. And so we go back to here when we had this type definition up here. yeah, anyway, we're down in these quantities that are resulting from this tome. Like I say, this pair what stuff, this is dot chords mess that honestly we probably don't really need. But this is, it's pulling out basically here are all the keys in this map, and this is how I know what the arms are when I actually run this. Like slow isn't actually that complicated, and it does kind of a neat thing. Like give me all of the names in this. So one of your exercises in the homework this time is going to be, let's write something like slow, but it grabs all of the faces inside of a type. So instead of getting all the names in the tome tapped by the tome, we're going to get all the faces in our current type and print those for you. So it'll do a similar sort of operation for that, which will be interesting. Anyway, test thread. Yeah, so what it does with get test arms is it gets that those functions, and so what it's actually going to be passing back out is the functions. Test arm is defined as a name and then func, right? Like the thing that results from as a trap from those values. And this is why when we look at test code, of which I had some open earlier. So let me see if I can find that test code again real quick. When we look at test code, one of the things you do in test code, this is lib. I want tests. One of the things we do with test code is we can supply a bar dot to an expect fail. And the bar dot is supposed to crash. So this is now run in mock, the metacircular user space, Hoon interpreter, and it is supposed to crash. So it's going to give us that crash back. It doesn't care so much like what the traceback is, but it wants it to crash. So when it crashes, then that is the correct behavior out of that bar dot. These others will also result in some sort of traps, and that's how test is going to resolve those when it deals with test arm. Wonder if expect, yeah, that's all in. There's a library that gets pulled in for test, I believe. Yeah, Fazless test. So that's where the actual definition for expect equal and expect fail come from, where it runs those. But this is how it runs an individual test. So let's see. So here, yeah. So here we're actually running through Mule. So Mule is our Mule wraps mock, and it's part of our evaluation, our user space evaluation syntax here for running these things. Yeah, so we can run it against the subject that we got from that core, from the actual test itself. Yeah, so yeah, homework's going to be doing a slow that's going to do faces instead of arm names. I think it'll be a little more straightforward than writing slow the first time would have been. And then the other one's going to be implementing a custom ARA. So you're going to implement PAT-UO, which is going to be octal or byte encoding, which is actually also like the rune creation, I think is fairly straightforward of an operation there. Questions?
For the slow implementation, like that'll be against a well-defined known type. It's not like we're using wet gates for that, right? I think like wet gates strip the type information or something. Because I tried to do this once.
Don't just write one that can accept a type and sort of recursively parses for faces and returns the P. the results from those faces.
Right. So it'll get the type. So since
Yeah.
it has the type itself, it'll be able to.
Yeah.
Yeah, deduce all this information. Okay. All right,
The
great.
one of the problems that you run into with doing this generally is that if you accidentally hit a context, then you just pulled in the entire standard library.
Yeah, that's
So you have to, yeah,
troublesome,
so
especially when you start
we will
pre-printing.
use it with explicitly constructed types. Will be
Okay,
our
very good, thank
pointer. What else? Tiller, any last minute heckles? Peanut gallery. All right. Say we're good for that then.